Hello everyone. Today we are talking about retrieval augmented generation, very new and advanced concept. So everybody uses ChatGPT. We have DeepSeek, we have Claude. So we ask them like, help me do my homework, or I want to break up with my boyfriend or girlfriend. Give me suggestions. So let's say there's a person who's asking, tell me about Italy. And she wants to travel. She wants to understand about the country or something like that. So this is a prompt that this girl is asking ChatGPT or Mistral or LLM, any other LLMs. Prompt engineering or prompting forward, you ask LLM, it gives you the response. How does a LLM knows so much? So it has been trained on this huge, humongous amount of data. What kind of data are we talking about? So we are talking about your Wikipedia or your internet website that is being given saying, hey, learn this. It's like a student going to college. A book is given saying, okay, learn this subject or something about automotive or computer science, right? So we learn and then we are knowledgeable, then we can answer questions. Similarly, LLMs are also going to do the same thing. But this huge amount of data, where can we store it, right? Generally, we store stuff in databases. But can we store the whole world's data in a single database and start searching for it? It's going to be very difficult. LLMs. We cannot use a traditional SQL Server, Oracle type of databases. People will not ask the exact same questions. So the best way this gets stored is in numerical format in something called as embeddings. Embeddings means you're storing the data in terms of numbers. Not It's not like table is one or chair is two or cat is four. It's not like that. Every single word will be stored in a set of numbers. It's a vector of numbers. Just to give you an idea, that 0.6, 0.1, 0.8, 0.3. If I tell a cat or a dog, right? 0.8 means is it a living being or is it a pet, right? It is a pet. 0.6, 60%. Is it a furniture? No, it is 0.1. So something like that. It will store all the words, all the text, or all the data in some kind of an embedding. Why we do that? Because it's not an exact match. Some people call a sofa as a sofa. Some people call it as a couch. So the embeddings for a couch and a sofa will be 0.86 and 0.88, for example. The angle between the two objects is very, very less. So when it does a similarity search, if somebody is selling a sofa and people are searching for couch, it will say that, okay, I'm not selling sofa, I sell a couch. It's the same. That's how similarity searches, embeddings, and all work. And our LLMs or chat GPTs will use the exact same thing. That's Praveen Kumar, that's me. Somebody is asking about which countries Praveen Kumar has traveled. You can see that there is a question here. That's a private information, or it's not public. It's not available on Wikipedia. Maybe it's there on some websites in World Wide Web. But your chat GPT would have been trained on a certain date and there is a cutoff point. After that point, it does not have any more information. So if Praveen Kumar has traveled, that information will not be available. So that is one. The recency or the latest information is not there. The second issue is private or something that is not publicly available. It will not be able to give an answer. It will say, I'm sorry, I'm not privy to that information, or I do not have that information. This prompt engineering, prompting, this is what happens. You call an LLM. It has been trained on humongous amount of data, which has been stored in these kind of embeddings. And then when people ask for questions, it answers, but any private information that will not answer. Now comes your retrieval augmented generation, which is the topic we're talking about. We'll also write code today. I will make you all also try this and upload your own bio or document or put some text somewhere and ask ChatGPT to answer the information that you have provided. LangChain is a framework. It does a lot of connections. It's an orchestrator. It's like a police officer controlling traffic in a very popular, famous junction. The first step is the PK's bio, the Praveen's bio is given, and LangChain picks it up. Let's say it's a PDF. Let's say it's a folder with text and data or whatever. LangChain will pick this up and convert the text to embedding. Right? If there is a sentence in English that says that I am going to the bakery and I'll have some snacks, I'll have some vegetable puffs, pastries, and cakes and all. First of all, your stop words are removed, like the, I, many of those words like between and all that will be removed. Then stemming and lemmatization happens in NLP. That is, going will become go. So it'll chop off the unwanted extra things. To make you understand this better, let's say there's a king, there's a queen, there's a man, there's a woman, there's a prince, there's a princess, and there is also a boy and a girl. That's quite about 4 or 8 different people. Now, if I have to store it in a normal SQL database and search, it's rows and columns. But if you do it as embeddings, it will, first thing, it will reduce the dimensions. It will reduce the amount of space that will be required. Second thing, not text, it will store it in binary zeros and ones or percentages. I'll tell you what that means is, let's say it will create something called as royalty. Yeah, king is royalty, queen is royalty, prince is royalty, princess is royalty. Whereas man, woman, boy, girl, they are not royalty. So your royalty will either be 0 or 1. Next is gender. So it will be again zeros and ones. Now, the next thing is whether they are young or adult. Again, if it is adult, it will be, let's say we'll call it 1, and otherwise it's 0. So if you want to represent a king, the amount of storage you'll have to do is so less. It will be 1, 1, 1. Because king, royalty, yes, 1. Then male, 1, yes. And adult, 1, yes. So 1, 1, 1. So if you're talking about the girl who's not the royalty, then it'll be 0, 0, 0. Like that, if you take anybody else, like a man will be adult, yes, so it'll be 1, 0, 1. So 1, 1, 1, 1, 0, 1, 1, 1, 0, like that. The whole data will get stored in such small format that it becomes easier to store, easier to search. Computers can understand numericals and binaries very well. What I would ask you guys also to do is create your own PDF, go to Wikipedia website somewhere, search for Virat Kohli, search for Narendra Modi, or search for somebody personality, and then you put that in a document and save it as PDF. I'll show you. This is Praveen Kumar is a technology leader over 27 years. He has been a speaker, motivator, World Summit in his early college days. Many things are there. Hobbies, traveling to China, animes, and many other information is there here. So what we'll do is we will use this document and we will do the whole querying using Reactive. So now that bio got converted to embeddings. Now this embeddings has to be stored somewhere. It's definitely not a typical SQL data, SQL Server, Oracle, or Postgres or MySQL. That will not be able to store embeddings. So a Postgre has PG vector, but that's a separate type of a database. Now in this vector database, we will store all these embeddings. And again, we are using LangChain for that. LangChain will help us do that. Now there is the question, which countries Praveen Kumar has traveled? The question also is the context to be given for searching. So this gets converted to, again, embeddings. So Praveen Kumar's data is in embeddings and the question is also embeddings. With the question converted as an embedding, the next thing LangChain is going to do is we can fire up a similarity search. Similarity search, what it will do, it will look at this question, remove unwanted text or whatever, and stemming lemmatization. Finally, it will realize that somebody is asking about the countries traveled, right? So if it looks at this vector database, it will see that there are so many things that is mentioned in the document that Praveen has worked in the United States, China, Europe. Praveen was in Turkey and traveled in Istanbul and many other places. So that will be there in the document. So it will fire the similarity search and it will get multiple results. This search results now cannot be shown as is to the person because that's a lot of text. We are looking at, let's say, 1 page, 10 page, 100 pages of text. If you keep searching in 10 different places, if it finds results, dumping it all to the user will be a bad idea. So what we do, that's where we use a LLM. So the question, which is the context, and the results, which is the output, both are combined and sent to your LLM, like Mistral or ChatGPT or anything. Now ChatGPT will take that search results and the question, which is the context, and it will respond to the end user that, hey, Praveen has traveled to a lot of countries. We'll see that actually. We'll write the code, we'll chat with this PDF and see the output. It'll say that Praveen has traveled to USA, Canada, Cambodia, China, Thailand, and many others. Think about enzyme engineering company. They have their compile data or results or product outcomes and outputs, PDFs, reports, travel policies, HR policies. So much information is there in the company that is not shared outside to the public, World Wide Web or wherever. But how cool it will be for ChatGPT to search only your data and answer only to your employees. So this is where again we can use RAG. The company's all the documents, PDFs, database, whatever will be stored in a place. And LangChain will first connect, get all the data, split all the data into smaller chunks or pieces. And then first thing it does is it converts the text into embeddings. That embeddings is then stored in vector database. And then whenever an employee asks a question about how do I design an enzyme, or how to do stock market MACD, what is the company's travel policy, can I take sandwich leaves, something like that. So what it will take that question, convert to embedding, then it will do a similarity search, right? Similarity search main advantage is even if they say sofa instead of couch, it will work, right? It will see what is the intent or what is the motive behind the question. It will try to do that, and then the results that it gets is sent to your typical LLMs that's either locally installed or somewhere hosted. Yeah, and this diagram hopefully clearly explains what RAG is all about. Initially, we were looking at the typical prompt engineering where the chat GPT is trained, there is a cutoff date, and it can only answer the questions for which it has knowledge or trained on, and no extra information it can figure it out. I want you guys to actually code with me if you can. We have the time, hopefully. It's not too big. It's a very small 15 lines of code. That's why we are taking this. It's go to collab.research.google.com. That's the first step. I hope you guys have your laptop. You do not need any softwares, no VS Code, nothing installed on your machine. Directly we'll do it online, which means every single person here who is listening, they can actually follow it. I encourage all of you to do this. It'll be a fun thing. I'm clicking on Google Drive so that my notebook gets saved on Google Drive. And then I'll say new notebook. I want you to do that. And then once it loads, it's loading. You'll have to give a name, and I already opened one here. I'm opening one again here, and then click on this on the left side, the folder, and then two things you can do. You can open up Google Docs or something and search for Narendra Modi or Virat Kohli or MS Dhoni or Shah Rukh Khan, whatever you want. Copy that data, put it in Google Docs, save it as a PDF, and then locally you can upload it. Okay. So now once you have this and once you have the PDF, take your time or see if you can download this PDF and upload it. The very first step is we want in this environment, in this Google Colab, we want to have LangChain and we want to have the PDF loader and we want to have one of the vector databases like I showed about like Chroma or FAISS, one of those. So let me install all that. You'll use exclamation mark pip because this is a notebook. It's not just pip, it's exclamation mark pip install. The first thing I want to do is LangChain. Then we want LangChain community, right? And then we need Mistral AI and also LangChain Mistral AI. LangChain connects to Mistral, so we need LangChain Mistral AI. And then we need FAISS, FAISS. So what is FAISS? FAISS is Facebook AI for similarity search. It's a vector DB only, like Chroma or Pinecone or any of PG vectors that you might have heard of. But Facebook AI, why I'm using here is because it runs in memory. You don't have to specifically create a chroma.db file or local folder, SQLite, nothing. It creates the database in memory at runtime and stores all the embeddings into that one. So I'm putting FAISS-CPU. Then we need to load the PDF. So I'm going to use PyPDF. That's a very popular utility. So if you guys have heard of transformers, right? We'll need sentence transformers. This is because as I mentioned, if you give 100 pages of text, sending that to ChatGPT, it's not effective. There's an issue with limitations and tokens. Let's try this. Pip install LangChain community, LangChain Mistral AI, FAISS, PyPDF, sentence transformers, and Mistral. I'm putting all this in one single line. I'll also share the code if you want later so that you can try it. So what this does, right, it starts, you know, installing all the necessary libraries. Now next is we need to set the API key. Yeah. So okay, for this I need to import OS. Yeah, it's giving. That's very nice. And then I'll use simple. I'll not use any .env and all. I'll just use a very simple os.environ of not OpenAI key. I want to use Mistral, so I'll say Mistral API key. Yeah, you can. It's just a text. You don't have to worry about the. You can give ABCD also. Then here I have shared the my API key here. Okay, so then I put the environment. So what happens now is this my API key gets stored in a variable called Mistral API key. So that's done, right? Now, oh sorry, what was that? Yeah. Now, it's very easy, just a few lines of code. Next is I want to import the necessary libraries, right? Import the necessary libraries. Now, what are the libraries that we want, right? The first one is the, we'll want to open the PDF. So I'll use the PyPDF loader. So import PyPDF loader. But before that, I have to, sorry, use from, sorry. So from LangChain community dot document loaders. So why document loaders? Because there's PDF you can load, or you can load the text, notepad and all that kind of stuff, right? So I'm going to use from LangChain community dot document loaders import PyPDF loader. Next is so like I was telling, the text cannot be sent full on. It has to be split and sent. So I'm going to use a text splitter. So langchain.text splitter, where it sometimes autocomplete comes, so you can use that. I'll use character text splitter. Then next step is we'll load the PDF. Yeah. So for loading the PDF, I'll use a variable called loader, and we'll call the PyPDF loaders constructor. I have to just give the file name. So my file name is about pk.pdf, which is my file, and then I'll say pages is equal to loader.load. Yeah. So then I have to split the text. So I'll use a variable called splitter. So splitter is equal to, remember we used character splitter. It is doing a character splitter chunk size is equal to 1000, overlap is equal to 0. So what is this chunk size, right? 1000 characters every time you take. I'll take 500 instead of 1000. And overlap I'll give, because see what happens, there will be a text like a word Constantinople, for example. If it gets cut at const const, and then the other part will go to the next chunk, we want to have some overlap. I'll put a 50 character overlap. So the whole page about Praveen Kumar, the 2-3 pages, or any other thing that you have 10 pages, each chunk, every time it takes and sends to your ChatGPT or Mistral or any LLM, will be 500 characters with an overlap of 50 characters. Then, okay, it automatically filled this for me. Docs is equal to splitter.split documents pages. So pages is this about pk.pdf that I loaded. Yeah. So I'm splitting that. Okay. After that, once we load the PDF, we'll have to convert the plain text to embeddings. So how do we do that? Okay. For this, I have to use, let me use Hugging Face. Hope you guys have heard of Hugging Face. I'll open a tab and show you. This is like a AI community which has everything, like a lot of models, pre-trained models, source code, connects to documentation is there. Mistral API key and all, you can get it from here, or you can go directly to Mistral. This is another way. So it's pretty good. And then when you have to create the API key, by the way, you can go to console.mistral.ai, and here there is create new key, which is what you guys should ideally do. LangChain, sorry, underscore community dot embeddings, right? So here you get all the different embeddings. I'm going to use import. You can see it's suggesting Mistral also. I'm going to use Hugging Face embeddings. It's quite popular. Now embeddings is equal to Hugging Face embeddings of model underscore. I have to just pass which model I'll use for the embedding. Yeah, it is suggesting. Actually, it did suggest right already. Yeah, sentence transformers. Okay, we can use this, right? I would use the other one also. Like it's similar to like word to vectors and all that kind of stuff. So it is suggested. I'll take that. Now we have to save this embeddings into a vector database. Which vector database? We can use Chroma or Pinecone, or for now, as I suggested, we'll use FAISS. So for this, I'll use from LangChain underscore community dot vector stores import face. So next line also it gave me db is equal to face dot from documents docs comma embeddings. Okay, I'll tell you what's happening here. First is we are telling that I'll be using sentence transformers, this mini LM, for doing the embeddings using Hugging Face embeddings, and then that docs I'll pass and the embeddings I'll pass. Right? So when I do that, it's going to convert the given docs into embeddings. Now next is I want to connect to the LLM. Yeah, so from, as I told you, I'm using LangChain, from LangChain underscore Mistral AI dot chat models. So import Mistral will do. Mistral, I think it's chat Mistral AI. No, it's supposed to have come. Okay, something's happening. Now I'll set the LLM. It's a variable called, I've just created a variable called LLM. LM is equal to chat Mistral AI model name is equal to Mistral 7-bit selling. I don't want to use this. I want to use anyone. You can use that. Whatever it's suggesting is also good. You can use that. I'll use Mistral medium. Yeah. Then I'll use next thing is I want to retrieve chain data. Yeah. So retrieve the data. So what we did was we took the PDF, converted to embeddings, and stored it. And I'll just show you the diagram just in case. Meanwhile, just so that we get an idea of. Yeah. So going back to our presentation, where are we? So the LLM is there, which gives answers to the prompts, but we had this pk dot about pk.pdf. Now the question is which countries Praveen Kumar has traveled, and then we are using LangChain, so imported and downloaded and installed LangChain. So we converted the text to embeddings, which we just saw, and then we are storing that into vector database, which is FAISS, which I just did. We created the Mistral medium. Then this is the chain I was trying to explain you. From langchain.chains, import retrieval QA. So what is this retrieval QA? Right? So QA is question and answer. So your LLMs come with various different types of chats, whether it's a chat interface or instruction. If you have seen deep Okay, I don't know if you can see my screen, sorry. Well, if you've used DeepSeek or Claude or others, there is an option called Think or Deep Research or Deep Think, something like that, where instead of just answering your question, it will also start explaining, oh, the user has asked me to tell about Italy. So Italy is a country, it is located in Europe. It has very beautiful things. It's been there for many, many years. It'll start finding all that information and start explaining it. Maybe the user is interested in travel and all. If you've seen that, that is a deep research type of a model. Question and answer is like you ask a question, it gives you a response. So we are using retrieval QA because this is retrieving the data of a PDF and also the question combining and then giving the answer. So for that, I'm telling this is the LLM, that is the Mistral, use that. And the retriever is db.asRetriever. So what was DB? DB was your FAISS, the vector database that we just had. Now let's ask questions about the uploaded PDF, right? So what I'm doing is I'm creating a query variable. We can ask our question here. The result will be this QA chain, that is the LLM with the retrieval data from the face, and then invoke this query, means execute this query and print the answer. Let's try this out, right? Now that we have uploaded the PDF and the embeddings are generated, what is this document about, right? That's my first question. Let me see if it runs, otherwise I'll have to rerun. There was a small typo earlier, I think that's why it was throwing an issue. So now that's fixed. Yeah, the document is a detailed summary of Praveen Kumar's professional and personal life. Can you see that? Wow. So it actually read through the document, converted to embeddings, and it's giving back in English. And I'll show you something cool now. Where all Praveen has traveled, because I have mentioned about my travels. So you're building like your own personal chat GPT, right? Like this is your Praveen GPT or your whatever you want to call. So it says Praveen has traveled extensively across Asia, Europe, and the Americas. Here are some of the places he has visited. So let's do some things. I will switch back to the collab. Yeah, yeah. I'll ask, has Praveen been to Cambodia? Right? So it will probably say no because there is no Cambodia present in the document, but it is so beautiful. This is what I want you to show. Yes, Praveen Kumar has been to Cambodia. He visited Angkor Wat and all the temples there. Angkor Wat is in Cambodia. You can see that Angkor Wat is here. He visited Angkor Wat and all the temples here. He had a good time in Pattaya Beach. When he went to Thailand, in Europe, he drove to Amsterdam. So it's there. Angkor Wat is there. So it is able to tell that he has been to Cambodia. So this is the beauty. LLM is also smart enough to derive that Angkor Wat is in Cambodia. So if Praveen has gone to Angkor Wat, it has gone to Cambodia. So that is, I think, something is a takeaway, that we are combining the power of your ChatGPT LLMs along with your personal data. You don't have to write a SQL query. If you noticed, I didn't write any SQL query. I didn't do any database SQL server or anything. I did not write React application or a backend application, APIs, nothing, right? Dump the data, give it to LangChain, convert to embeddings, push it to your ChatGPT, LLMs. I mean, I'm using Mistral only because Mistral API is free. All of you can try. If you go through this whole video end to end, you will realize that everything actually works. Pip install. After that, set the environment. Then import all the libraries, like load the PDF and splitters. And this is the PDF I gave. If you save a different PDF, you could, yeah. If you give a different PDF, it will search that PDF. Then split them and to send it to the LLMs later. Hugging Face embeddings is what I'm using for converting to embeddings. And Face is the database that I used. Everything is ticked now. Earlier there was a small error. And I'm saying use Chat Mistral AI. That is the LLM, not OpenAI, ChatGPT, or DeepSeek. I'm using Mistral AI's chat module, and I'm using the Mistral-medium model. Then we created a retrieval chain. Why we are creating it as a chain and not just a, I'm using model.invoke instead of, or chain.invoke instead of just a run, because the previous question also, it has tried to remember, right? So uh, does Praveen watch anime? Yes, Praveen loves watching anime, has completed watching. Now I'll say what's his favorite anime, right? And then you will see the outcome. So mine is One Punch Man. His all-time favorite anime is One Punch Man, which he has watched at least 3 times. So it is keeping the context also what I've asked previous and all. That's why this is running like that. What we did, right? So we were trying to build a PDF chatbot using LLM like Mistral AI, right? So the objective was to upload a PDF, convert that embedding, give it to Mistral, ask it to learn. Hey, this is my data. Take a look at it, understand. Then I'm going to be asking you questions. And then, yeah, this interaction with the PDF was what? Like you gave a brand new PDF which it had no clue on, and then suddenly it became an expert in that PDF and started answering questions that you are asking. Right? So it's like giving a instruction manual or like a detailed research paper to an assistant and telling, find everything about it. I'm going to ask you questions. So these are the technologies we used: FASs, LangChain. Right? I explained about loading the PDF document by using PyPDF. That's one of the important steps. Then why did we split? Why did I use the character text splitter, right? So we talked about chunks. Our AIs generally have limitations, like I was telling. So to overcome this, we are breaking it down, like 1,000 characters, 500 characters, and whatever. The advantage is also because these smaller chunks are indexed, it will be very fast and you can retrieve data really quick. It's like you're having a telephone directory book, and somebody says, look for the name Joshua, right? So you will go, you will skip at least the first 10% of the pages, because A, B, C, D, E, F, G, H, I, J, right? Somewhere closer to the center is where J will be coming. If somebody says, I'm looking for the name of someone starting with Z, like Zahir or Zainab, then you'll directly go to the last few pages of the thing. So you're not scrolling through every single page. That's a very fast way of retrieving. We talked about embeddings, converting your given data into zeros and ones of multiple dimensions and columns, where I'm telling a cat and a dog, a table, a chair, they'll all get different numbers for their embeddings. So chair is a furniture, table is a furniture, sofa is a furniture, couch is a furniture. All this will have the non-living thing set to zero point 0.9 or 1.0 or whatever, right? So similarly, cat and a dog and a cow and everything else will be living beings. When it comes to a tiger, that's also a living being. Then there will be a question about whether they're carnivorous or herbivorous. There, some will be zero, some will be one. So we don't know what the columns really are, but there's going to be a huge hundreds or thousands of columns in which zeros and ones are going to be stored. So when people ask for questions, it will be able to retrieve it really, really fast. We did use Face, like I said, but I also encourage you guys to try Chroma. I mean, I would suggest that try out if you want Pinecone, or PG vector is there. Postgres has a PG vector. That is also something you can use. Face is the easiest for you to try out live. If you're doing it today, right now, while we are doing, I would suggest Face. Facebook AI for similarity search. Very fast, as you saw, how quickly it was giving all the answers. So that's the advantage. Now think about it like a very efficient librarian, right? Who knows where all the books are and which book has what type of content and stuff. So they're always going to be able to help, and it does semantic matching, right? So that's also another important thing. So we have syntactic analysis, semantic analysis, pragmatic analysis, keeping the memory or context in mind. And the same words, right? Like, oh my God, can mean two different things. Like, somebody wins the lottery. Oh my God, I won the lottery. But then there's this other thing that, oh my God, this guy met with an accident, right? So the same words, based on the context, the emotion or the meaning itself will change. So we did connect through Mistral using the LLM is equal to chat Mistral AI, and so I again ask you guys to check this out. You can go to Mistral.ai website. It's free. The APIs are free. It's all open source project. It's a very good community. People are contributing a lot. It's really a nice LLM, I would say. There is no charge. So there are limitations, but at least you can try it for free. I was able to build this whole thing using Mistral without paying a pipe, right? So yeah, so then finally we did the Q&A chain. So how did we do that? So whenever the question was asked, the face first retrieved all there were four different places where my travel things were listed out, but it took all that, gave it to ChatGPT along with the context, which is my question, and then it came back and said, "Hey, convert this." It's like I want to, I'm telling my stenographer or somebody who's my assistant and telling that, "Hey, send a mail to this guy saying that I'll not be able to go to this trip. I'm very busy. Also, tell him that we'll do it sometime in October and all." I'll say in my own words, in my local language or whatever. The steno is going to be very formal about it, write a proper letter. Dear Anand Joshi, for example, Praveen is really sorry to say that he will not be able to make the trip, is busy, all this, right? So that's what these LLMs are doing. We throw them a bunch of data, we give the context, it will rewrite it, generate the beautiful English, and explain. So that's what we did, and I typed the question. I got the answers. It was able to understand. The best thing we saw was I asked, "Has he been to Cambodia?" There is no word mentioned in the whole document called Cambodia, but if it was just a simple database search, it would have come back with a no. If it was even just a vector search, it would have come back with a no. The vector search or the similarity search combined with your LLMs, what made it more intelligent. Yeah? So that's what we did. So I hope this was useful. There is also more sessions coming up for the newer context like model context protocol, function calling. I think even RAG is the most commonly asked question now. If you're going for a job interview and if it is related to generative AI or AI in general, most of the time people are going to ask you questions like, even if you go for an AI interview, first thing they're asking is, do you know what is generative AI? If you say, yes, I've been working on Gen AI, they're going to ask, have you heard of RAG? What is RAG? Why is it used? So some of the things you can mention is, if a company has its private personal data, we can use a technology like RAG and then connect and search, retrieve, and give it like answers like how a ChatGPT or a LLM does. Yeah, that is the whole point. So guys, wish you all the best, and feel free to ask me any questions if you have. And I hope this session was useful. If you like the content, please feel free to comment and like and subscribe. Still hope this was useful. Yeah. Thanks, guys. Bye bye.